research section of RITSEC, or as we like to call it, the second hour, wherever. Yeah. Welcome. We just call it research, actually. If you have not done so, and you have not heard me say this enough, please sign in to signin.ritsec.club. That is the URL to sign in at. It's important for us to maintain a roster so that way our sponsors can see who you are, and we can also make sure to tell the lovely people in the department when they ask, hey, how many people come to the club? And we can give them a number and have it backed by facts and data. So, these are our sponsors so far for the spring semester. This is open to change. So thank you to our sponsors. Okay. All of them are great in their own individual way. And without further ado, let's start on to the announcements. First announcement, we have Professor Zhao here to talk about some research opportunities and some other stuff. So turn it over to him.
Thank you, Nick. So this is a very exciting group, huh? I didn't expect to see so many people to be here. So this is my first time to be here. So I'm at RITSEC. So I'm an assistant professor at the computer security department. The purpose for me to be here is I want to recruit some students to work with me on all kinds of security projects. So I have many interests, and my goal is to publish top conference papers. And
Can you just hold that?
oh, sure.
Yeah,
Yeah,
it's fine.
Yeah, I think it's fine.
Or clip it, yeah, however you want.
Okay. So no, I think this one works better actually.
Yeah, that's just for the recording.
Oh, I see.
We're
Oh,
streaming
really?
now. Yeah,
So there are more people watching me.
there could be. Yes.
Okay. Okay. I'm flattered. Okay. 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 So I do all kinds of research, especially at a system level and the software security level. I'm interested in all kinds of cache side channel attacks, operating system attacks, and also design defense techniques. So there are several students actually here working with me in all kinds of security projects. So if you go to my website, you search my name, you can see what kind of projects I'm working on right now, and also I worked before. So this semester, actually, I'm also leading a CTF team to work on embedded system security, which is all guys my MITRE. So we're designing a game console and also try to hack other teams' game console. So if you want to work with me, just Google my name and read my papers, the introduction, to see what is there anything interest you. Okay, so thank you very much.
Awesome, thank you. Awesome sauce. And if you need assistance getting to an email or something, you can hit up anyone on eBoard. We'll be able to help you out with anything you might need. Cool, thank you. All right, next up on to the announcements.
Aw, I'm flattered. Thanks, guys. All right, so if you don't know me already, my name's Sean Newman. I come up here a lot to shill my competitions. Next one I'm shilling. ISTS, the Information Security Talent Search. This is actually ISTS 17. It's not the 17th one, but its number is 17. It's a red-blue competition, which means teams of 5 people are given infrastructures. It's like Active Directory, websites, email, other stuff that we're not going to tell you yet. And you have to defend it from a team of professional penetration testers and hackers and stuff that we bring in to attack y'all's services. You can also attack other team services as well. And the goal is to keep your boxes secure and keep things uptime. In addition to that, there's a CTF, there's a King of the Hill portion, there's injects, and there's other fun stuff going on. So there's a lot at ISTS. If you haven't done it before, I definitely recommend you consider putting together a team. It's a great way to learn a lot of things about security in a short span of time. It's February 22nd to the 24th, which is coming up really quickly. Teams are 5 people, and once you have 5 RIT students put together on your team, go to blueteam-ists.ritsec.club. There's a Google form there. You can put in the names, email addresses, t-shirt sizes, and dietary restrictions for all 5 team members on your team. The team registration fee is $125. That's $25 per person. That covers the cost of your t-shirt and some of the food during the event. Be there, be square.
And there's going to be other schools that come to this too. We have quite a few of some cool schools coming this year. Changes every year. ISTS is awesome. You should definitely sign up or consider signing up. Or if you miss this, maybe you want to help out with White Team, you can also do that, which White Team is helping run the competition. So hit up Newman for more information, or just go to that link for blue teaming. All right, next up, Jack McKenna.
After high demand, we're bringing back Halo Game Night this semester. It'll be February 1st, which is a Friday. 8 o'clock, we'll be in Sec Lab playing Halo on the lab machines, so come on out, have some fun. You don't need to bring anything. You are welcome to bring your Elite Gaming mice if you want, but you don't have to. We're introducing our first ever Hackathon, which is going to be a 24-hour come hang out in the labs, write some cool code. You can build blue team tools, red team tools. If you want to write malware because you're applying for the red team, you can do that. February 8th to the 9th, 5 p.m. to 5 p.m. Come out, build something cool. You can come with a group. You can come by yourself. You can make groups there. It doesn't matter. Just come and build something cool. There is limited space, though, so please RSVP soon. The lab is only so big, and we want to make sure that we can provide for everyone that shows up. So tiny URL at the bottom, that's the sign-up link. Fill it out. Let us know you're coming.
Yeah, that's an Eventbrite link now, right?
Yes, sir.
Yeah, so there's tickets to this. It's much different than other things. So first come, first serve ticket operation. Go to that URL, sign up. Because again, food will be provided, and the lab is only so much space. So that's important. I think I can, nice. I can reclip. Alrighty, so on to the news for the week. Follow along at home in the newsletter, which contains letters and news. So first up, we have the lovely RCE in apt. So how this basically works or came about is that apt doesn't always use HTTPS as part of its way to get packages. So apt is a package manager first off for some Linux distributions. So in the event that someone can man in the middle your apt queries, they can send back very specific apt files through like a redirect and then put to their app server with their own malicious stuff. And then there's some like post scripts that get run with apt that then can just basically do whatever they want. So here there's an example for a POC of just running some print statements and saying I am root, which is cool. So this is kind of like melded interestingly with a conversation that's been going on a little bit recently in the apt world. There's a lot of people that were very heated about like requiring apt to use HTTPS. Some people think that signatures are enough and that should only be what you use. Like you sign each of the files that are sent back and the client will verify that the signatures are accurate. But HTTPS the people who say HTTPS should be required would say that that's not enough because of reasons like this, where man in the middle can be a real problem, especially if you're getting your verifying keys also through that same process. Because someone could just man in the middle of the verifying keys, so what does it even matter at that point? So that was basically all this was a lovely little RCE. This is for apt clients, so this would have worked on any Ubuntu image that you have going on. So that's pretty cool. Next, there was a data breach, so to speak, where there was about 773 million records. So what this was is that there was a random, from the site Mega, which was originally way back in the day Mega Upload, So basically, there was this huge trove of like just email address and like password in this giant like mega file directory. And like someone stumbled upon it, and it was like 2.6 billion entries in that giant thing. After normalizing the entries, removing duplicates, and getting rid of junk data, it comes down to 773 million, which is still quite a sizable thing. These sorts of like email addresses and passwords pairs don't necessarily come from one company. They just come from like all over the place, and it's kind of hard to like link and verify all of these things without actively just logging into people's accounts. So that hasn't really been verified to too much of an extent. But this giant collection has been uploaded to Have I Been Pwned. So if you want to check, you just go to Have I Been Pwned, which is a website where you enter in your email address, and it will say, yes, you've been pwned. Or it will say, wow, you're pretty cool. You haven't been pwned yet. So if you want to check if you've been affected, go over there. Okay. And then finally, there was a 36-year-old vulnerability in SCP. So how this basically worked is that SCP, which is the secure copy, it's used for like copying files over SSH, typically from one computer, one host to another. The issue was that SCP client was not verifying that the file that you got or the file that you put was actually the file that you received. So like someone could, again, man in the middle it and just change the file. They didn't even check the file name. So like the name could be completely different, which could be its own little vulnerability. That's why this is a vulnerability, not really an exploit. But yeah, that's pretty interesting. Just a little thing. Been holding along for like 36 years. And cool. I think that concludes the news, unless anyone has any questions about those articles. All right. So, thank you, Newman. So in keeping with our web theme in the education section, the first presentation we have for this year, this was planned, is an introduction to Nginx modules by yours truly. So let's, thank you, let's get started. So this is a new year, new Nick. So I'm Nick, this is my intro slide. Oh, hey, it's pretty intense. So what is this talk not going to be about? How to use Nginx. It has nothing to do with setting up an Nginx server and making sure your configuration is set correctly and like running a web server. It has everything to do with writing what are called modules, which are basically like plugins or whatever the term will be for whatever you're used to, that get used inside of Nginx as part of the operating procedure. And I will go into that in a moment. So why am I even bothering to make a talk about this? It's just a plugin. Well, writing these modules are like notoriously difficult because there's actually no documentation from Nginx themselves on how to do these. They're just like, yeah, you can write modules. And you're like, oh, wow, that's cool. And the foremost authority on writing these modules is a blog post from 2007 that's occasionally updated. The last update was in 2017. So that's fun. And if you want to do something even slightly different than what's in that 2007 blog post, good luck, because there's absolutely nothing out there to assist you other than just looking at Nginx source code and going like, well, how do they do it? And then squinting at GitHub or if their HG solution because they use Mercurial for their source code as opposed to Git. Thankfully, there's a copy on GitHub, so you don't have to do that. And yeah, like I mentioned, you have to read a lot of Nginx source code if you want to do anything that's even remotely different than like how to say hello world. So you want to build a module. Well, there are 3 different paths forward if you want to build an Nginx module. There's a handler. What Nginx handlers do is that they're basically the part of the Nginx pipeline that creates the response. So when you hit an Nginx server, it's going to process your request, your HTTP request, and it's going to output an HTTP response. A handler is what is responsible for creating said response. So it will allocate the memory, it will put the values into the buffer that are needed, like the response headers, as well as like the actual response body, and all that stuff. The filters, which operate after the handlers, are basically used to edit response body and headers in real time. So those are just kind of like after the response has been formed, they're sent through the filters, and the filters can do quick edits to like make minor changes. So like if you wanted to write an Nginx module that would like make sure that all of your script tags had a SHA sum on them for HTML, right? That could be done in real time in an Nginx module that does that for you. And the purpose of that would be to protect you from someone from injecting a script, injecting code into one of your script tags. And then finally, there's load balancers. I'm not going to go too far into those, but they are exactly what they sound like. So Nginx modules that are just load balancers are for you to add like specific logic to how Nginx will proxy your request either to other Nginx servers or just internally how it's going to handle that request in its pipeline. And of course, you can just mix and match these 3 different types. And we'll get into like the code. This is a very code-heavy presentation. You'll see in a sec. Maybe you want a handler that also has a filter on the back end, or you just want a filter, but you also want to do a handler for a very specific request that's coming in. You can do all of that in just one module. You don't have to create like one for each thing you want to do. And each one of them have their own little like niche differences between each other that just make them oh so different. That makes implementing them oh so hard. So let's talk about some code. So here is what a generic module will contain. There's quite a bit of stuff on this slide, but there you can look at this. This is actually segmented into 2 separate modules. We have a Hello World module on the left, and then a module that will, I didn't set up the demo, so won't have a demo. I can show you later, though, if you want. That's very unfortunate. There is a other module on the right that I wrote called Headshot, and I'll talk about that in a hot minute. So this is a struct that you write inside of your module. Its type is Nginx module _t. You'll note when you look at the code that you're going to see, Nginx has its own type for almost every single type that you can possibly imagine. So like down here, you'll see Nginx string. It has its own string type. It's great. So over here, this is what a basic Nginx module struct will contain. You'll say the version of the module. This is basically a constant at this point because there's never been a version 2 released. So this is the only type of module that there is. The second is the module's context, which I will talk about in a moment. But basically, it's the context in which the module will be injected into the pipeline. The commands, which we can see some examples of a command down below. Basically, what the commands do is it's a separate struct, which basically will say, how do I call, as a user, this module to start working? So like here, you define what's called the directive. So we're going to talk a little bit about Nginx configuration files. In your nginx.conf, you would typically say a directive, like you would say proxy pass if you wanted to pass something to a proxy, or as a proxy. Or you would say server if you wanted to denote the server string. That's what this directive is here. Here it's just called hello world. So if you wanted the hello world module to run in your Nginx conf, you would just say hello world. And then it would be like, okay, here is how you dictate how Nginx will handle the directive. So like sometimes you want to say hello world on, or you want to say hello world off. But sometimes it's not that easy. Sometimes you want to say something like a header. So you would say add header host, and you wanted to add a host header. That's more complicated than just on or off, and you'd say what the type of your parameters are here. This is a call to a function that we'll talk about in a minute. And then you need to terminate your commands with something called Nginx null command, which is just a bunch of zeros. So moving back, that's what a command will look like. Basically, it tells how Nginx will process the configuration. Then below, we have the module type. This is an HTTP module. I haven't seen many other ones, but I suppose you could write a TCP module because Nginx can handle that, I believe. And then down at the bottom, so then we also have like init master. So if you're going to add something into the pipeline of Nginx while it's starting, when it's initializing its master process, which is the first thing that Nginx starts when it starts, then you would put it in there. If you want something to start when the module is initialized, then you'd put it in the init module section. If you want something to get run when the process starts, when the thread starts, when the thread exits, when the process exits, the master exits, you have lots of little endpoints that you can put in. And then as an example of one, over on the right, we see the Nginx headshot module gets put into the init module. And what it's going to do is that it's going to take the Nginx configuration file that was read in by Nginx when it starts, and it's just going to force Nginx to run all of its processes as root, which basically means that no matter what you put in the Nginx configuration file, Nginx will run as root, which is a pretty neat thing. That's why headshot's pretty cool. So that's basically the end of that, and then you have to end it with the padding, like I said. Down here below, we have the Nginx HTTP Hello World, which is part of the configuration setup. So this is basically some boilerplate code that you use to process the parameters. So that was the on or off thing I was talking about before. Okay, so this context thing I was talking about. This is about when you want to hook in your module to the Nginx pipeline specifically. So like, you have a pre-configuration before the configuration is loaded, post-configuration after the configuration is loaded. You have the create main configuration. So inside the Nginx configuration file, you have a section called main, you have a section called server, and you have a section called location. The main is just the outermost, it's not necessarily denoted. And then you can just put here different hooks that you want to activate when the configuration is read. So we don't do anything for like a basic Hello World module, but on the right side for headshot, we hook into post configuration. And basically what we do here is that after you read in the configuration file, we inject our module into what is called the HTTP content phase handlers, which is basically a linked list of different handlers that handle the content that's responded to. So basically this is a handler that will process a response. So we need to hook it there, where the hello world just returns something, regardless of what's going on. This also puts it first. It's just syntactically. So headshot is supposed to be malicious. That's why it's a little bit different. So here is an example of what hello world does, the hello world module. Basically what the core logic of your module itself, how it will handle a request. So this is one of the a handler module will do. So as you can see on the top here, we take in an HTTP request. They do some buffer allocations. They set some response headers. They allocate the response body. And then they're going to attach, basically, this is a string that just says hello world. And then they set the header status to 200. And then they correct the content length. And then away it goes. And this is sending the headers, but this down below is actually slightly different. Because like I mentioned previously, after the handlers are done, they're passed on to the filters. So this is just calling the filters after we're done with it. So this hello world module will literally just take any request that Nginx gets and just return the string hello world. This is an example of a filter module. Very unfortunately, I couldn't find a picture on GitHub. This is what the Mercurial equivalent looks like. So basically what this one does here is that it will find anything, the letter capital X, and if it does that, then it returns a 401. So if in the response that was generated by the handlers, there's any capital X anywhere, it will just return a forbidden. So that's just an example usage of a handler. I don't think there's any practical reason for that, but there's some other things that are much more useful for doing inline maturation, like I mentioned earlier with the SHA sum for the script tags. Again, here's some stuff from Mercurial. This is the load balancer solution. I'm not going to get into it because these get very, 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 very complicated. But basically this one here is hashing the incoming IP address and it's going to determine from that hash which upstream server to send it to. But that's an example of what a load balancer module could do. Because by default, Nginx's load balancing is pretty basic. I think it just does round robin. So if you want to do anything else, you need to load a module that does something a little bit more advanced. And that's basically what these load balancer modules are for. Sad. Sad that I don't have that set up right now. I forgot about this. But what I can do is I can show you some copy and pasted output of it. So we in theory, we have Nginx running on a server. I guess it's localhost in this situation. And what we can do, can everyone see that? I think so. I just want to make sure. Cool. So what we can do is if we curl localhost, and then we do tac header, which says basically I'm setting a specific header in my HTTP request, and I just say headshot, and then the value is lsla/temp. And then it will literally return the output of that command. That's what headshot does. Do I do an example with who? No. Headshot, like I mentioned earlier, remember it changed who Nginx runs worker processes as. So this will be executed as root. You can also touch things. This is another example of ls. And then below is what happens if it doesn't have that specific header. So what we have here is just curl localhost, and then because that header was not passed, my module will not actually act on the response body or will not create the response body. So instead, it will just return whatever Nginx would normally return, which here is the Nginx example page, but it could be a fully functioning website. And then here's what the process tree would look like if headshot was used for a reverse shell. Basically, you're going to see like the master process, and then the child, that's the worker process, because that's how that works. And then below that, you see this shell execute of like a netcat of bin bash back to your port, basic reverse shell stuff. But it would be kind of obvious to see that. But that's just what it looks like. It's kind of cool. So that's headshot. Going back. It's kind of a cool thing. Okay, so the main takeaways. Nginx modules are kind of rough, but you can do basically anything you want with them. You can make Nginx do anything that you could possibly imagine. You could actually write an Nginx module that's just an entire website, and it serves the website from inside Nginx. So Nginx modules can actually be either compiled into Nginx itself, or they can be loaded dynamically. So what that means is that I could compile my module and just have it be a standalone thing that I could just plop into the modules directory, and Nginx is like, okay, and then it loads it in, and then headshots on your box. Or I could literally just compile in my module right into the Nginx binary, so there's actually no artifacts on your box, unless you were to grep in the binary itself for headshot. But that's really easy to change that string. Was that?
Didn't you like do a checksum? Check that hash?
Yes, but the problem is Nginx compiled on GCC version 4.3.2.0.1 will be different than 4.3.2.0.2, and the checksum will just be yikes, at least in theory. So you can edit responses, and you can load balance requests. You can edit core Nginx functionality. So like the root thing, that was not really documented anywhere. That was just like me going like, oh, after you load the configuration file in Nginx, I can just say, oh, I read root. Cool. So now all the workers are running as root. Modules can be compiled in or like dynamically, like I just mentioned. And this is a fun fact. Nginx itself is just a collection of modules. So underneath the hood, that's all Nginx is. There's a basic runner, and then they built a bunch of modules. So like over here on the right, we literally see the command stack, like we saw with all those other modules that we were looking at. This is nginx.c. So if you were to go to nginx.c, this is what you're going to see, which is the exact same code. And then finally, but not least, this is possibly the greatest case study for the need for documentation, because it is god-awful to write these things. So yeah, it's very important if you create something to document it, especially if you intend it to last, because there's a lot more things that people could be doing with modules, but no one knows how to fucking write them. Questions? Okay, yeah.
So if you have the module in the module folder, do you have to explicitly say load in a config file, or does it just get loaded into build straight away?
Yes, yeah, the first one. I believe you need to say, well, you can say load all modules from this directory. But yeah, in the nginx conf, you would write like load modules, or I don't know the exact directive, but guess what? That load modules directive is also a module, right? It's just another module, because that's all nginx is. Any other preguntas? All right, thank you very much. And next up on our presentation list is a fellow who goes by the name of Joseph. He will be presenting on CVE 2016 6366.
Really wanted to draw it out for dramatic effect.
So without further ado, here is Joseph Graham
I got up here.
on CVE 2016 6366.
Sort of.
Sort of. Joseph Graham edition.
Yeah. Hello. I didn't actually find the CV. So if you're looking forward to a presentation on how someone hacked their stuff or found a vulnerability, you're not going to find it here. I apologize. But it still is a cool presentation. So, and I got to put this in my pocket. Man, back at my day, I didn't have to put 4 different cables on myself just to give a presentation.
Yeah, but nobody could hear you either.
That is true. Boop. What am I doing? I swear I know how to use a computer. All right. Hi, everybody. This is a presentation about how I took a proof of concept exploit for a CVE that I was kind of interested in but didn't work on a certain type of firmware and made it work on a version of the firmware that was vulnerable but didn't have a working exploit. Just as a quick disclaimer, I wrote this presentation because I'm going to be doing a job interview in a couple of days, so it is completely devoid of memes, so I apologize. It's also a fairly serious thing. And at the end of it, if you have any feedback on how I gave the presentation or if I should add anything, feel free to give it in addition to having questions. Because of that, I have an overview slide, which nobody ever does unless they're giving a formal presentation. But basically what I'm going to go over, this vulnerability is a vulnerability in the Cisco ASA. The presentation is to a networking team, so I don't have any slides in it, but basically the Cisco ASA is a firewall. There are multiple different models from a small home office or small office, home office use, all the way up to firewalls that you would see in an actual enterprise. And they all run the same code base, which makes it really easy to develop exploits for it because you just buy this really small box and then you write the exploits on there and then you can use it everywhere else. So I'm going to go over the structure of the firmware itself, how the OS runs, and ways that you can modify the firmware so that it can speed up using or developing exploits. Then I'm going to actually explain how the vulnerability works, and then the steps that I took to fix the exploit. This is me. The important information in there is that I've done a couple of things, and this is my flex. All right. Oh, actually, I had speaker notes on here. The OSCP lent a hand in figuring out some components of fixing this exploit, and it got me interested in binary exploitation. So if you're interested in penetration testing and learning how very basic buffer overflows work, I would highly recommend, if you have the ability to have someone else pay for it, doing the Offensive Security Certified Professional certification. So Let's talk about the ASA. The firmware itself is just a .bin file, like you would expect on a lot of different like embedded computing environments. But if you use binwalk on the image, you can see that there's actually a whole bunch of stuff in there. The most important part that we're going to focus on is that there's a rootfs.image in there, right at that little offset right there. And if you decompress the image, you see that we have what looks like a normal Unix like operating system with one minor difference. There's an ASA directory in there. If you could take a guess, that directory is going to be really important later on in the presentation. So the ASA, unlike other Cisco routers which run iOS, is actually like just running on BusyBox Linux, which is a version of Linux that is stripped down and only has like a couple of different binaries in there. Usually you'll find it on things like your home router firmware, but you'll also find it on your ASA firmware. The security kind of depends on what firmware version there were. Up until 9.16, it was all 32-bit because they didn't have any hardware that had to worry about doing 64-bit operations. But at that point, they had come out with newer versions of the firewall, which they wanted to like bring into the 21st century. ASLR, which is address space layout randomization, NX, which means you can't execute in areas of memory that you're not supposed to, like read-only data, and position independent execution, which is similar to ASLR. All were introduced in 9.6.2, which was October of 2016, a year and a half after they introduced 64-bit. This is important because literally all they had to do to change this was just recompile the binary with certain flags set, especially because they were running it in Linux. Very easy to do that. But it took them around when this vulnerability came out for them to actually include these protections, which makes sense because this vulnerability is extremely easy to exploit. Because unlike with most buffer overflows, but like the last presentation I gave on this topic, most modern operating systems and most modern applications don't allow you to just, hey, this address right here is where this instruction is going to be all the time, in part because of those protections that I just talked about. Yeah. So the /ASA directory contains startup scripts and the OS binary itself, which we'll get into in a little bit. So the way that the operating system actually boots is that it starts up BusyBox, and then it reads through each of these files in order. So I'm going to go through each of these files and talk a little bit about like what you can find in them. And you'll see that there is, oh, hit the microphone, cool. You'll see that there's some really useful tools, at least in some of them, that will work in our favor when trying to figure out how to do exploitation. So this is a NIT tab. Can people actually read that? This was step number 1 with figuring out this presentation. So basically, what this file does is it is run when the operating system first starts and starts like opening services. One of those lines, the one that I'll walk over, because when I give this presentation later, it'll be a smaller screen. This one right there, make sure that you can't actually access the BusyBox operating system while the ASA is running, because obviously you don't want to be able to reach the underlying Linux effectively distribution when the entire operating system is built into one binary. Some of the other things that are useful are the commented out lines that show how logging and TTYs might be set up for like development and testing. So this right here just says like, hey, put a TTY, which is like the thing that you actually type into to run commands, on TTY1 with a certain baud rate. Yeah. And there's a bunch of stuff down here that describes how logging would look if you were actually developing it. Obviously, you're not going to want that running in production because you don't want to have a bunch of messages logging out onto the terminal. But when you're developing the operating system, you're going to want to be able to like test stuff. So my guess is that when they actually do develop the operating system internal in Cisco, they comment out these lines in the firmware so they can figure out if something is broken. The most important part about this file is that it calls /etc init.d/rcs. Trust me, it is on there, even if you can't really see it very well. All right, you can actually read those screenshots. So these are the two scripts that actually matter. RCS is another standard Unix file that basically just says go through everything in init.d, and if it has a RCS in the first part of the file, that means that that's like a service start script, so call it. The one on the right is S59ASA. It's another cool thing that like shows they have other scripts in place for debugging versus production. But of course, because it's like a production image, unfortunately, we don't actually know what the RCS debug thing looks like. But yeah, so the important part there is that if the file exists, it calls that. So what's actually in that file? This is what's in that file, and that's even less able to be read. So I'll just talk about the important parts. There is a line towards the very top, actually the first thing that's not commented out, that calls serial_init. That just sets up serial lines so that people can configure the router when the operating system is running. It sets any TTY except for the serial to like a weird baud rate. So even if for some reason you were able to like get the other TTYs to function in like a production environment, it would be more difficult to be able to access the underlying Linux environment. Most of the script isn't really useful except for one very specific commented out line, which is right here. Again, I'll read it for you. Basically, what that says is it outputs a line that says like a command that has the system await for GDB to connect on boot. That's the GNU debugger. So this is like super convenient for anybody who's trying to like develop exploits for ASAs, because this means that we can use a normal debugger that we use it like during our everyday work with a couple of small modifications to connect into the operating system. So like say if you run an exploit against it and it crashes, instead of having to read a very long crash dump, you can just like look at the memory of the program as it's running, look at the values of the registers, stuff like that. Super convenient. I use that a lot during this during this project. The last thing is that /temp/run_command, which is also kind of difficult to read, is just like a file that's in here that commands get output into that gets called at the end of the startup process. All right. So I've been talking about like this thing Lena. Actually, I don't think I've talked about it yet. But basically, Lena_monitor and Lena itself were also in that long list of commands. These are the actual operating system programs themselves. This is like the coolest thing to me about the ASA itself is that it's literally just one binary. It's a 30 megabit packed ELF binary that the entire operating system runs on. Like the routing, it directly pulls the PCI interfaces so that it can do the networking with the actual ports. Super cool, which also means that we can throw it into things like IDA without even have to like pay for it because it's an x86 binary. Super convenient. Lena Monitor is just a program that gets called and helps you enable the debugging stuff. That's how the GDB server gets activated on startup. So now that we know that the firmware has all these cool things in there, what do we do now? Let's modify it. So as I described earlier, you can use binwalk to see what's inside the firmware file itself, but you can also use binwalk to extract everything that it can find in there. Obviously, there is a way to do this like mechanically, so you can take one step, like decompress the file system, go in and change things, recompress it, and then put it back on the firmware, then put it back on the ASA. This is super tedious. I wrote a script that did that for me when I first started this project a couple years ago. But then in September of 2017, NCC Group released a whole bunch of blog posts describing how they've done some ASA research. And specifically, they released a bunch of software that allows for very easy modification of the firmware. So I just used that because like, why bother using your own janky script if someone else wrote something better? I used these tools to create two different firmware images, one that just regularly ran the operating system, and then one that would allow me to debug remotely. And then I put both of those on my ASA. So now let's talk about the vulnerability. Basically, it's a very simple stack buffer overflow and the simple network management protocol handler for the ASA. literally the only information that the attacker needs to know is the community string that was configured for SNMP. Most configurations, just by default, use public or private for their community strings. So that makes it very easy. Like, you could automate trying to exploit a bunch of different systems just using these default community strings. What's up, Sam?
So is this just for SNMP v2, or is this also applied to v3?
That's a great question. It's just 1 and v2. Obviously, with v3, maybe not so obvious. With v3, SNMP introduced usernames and passwords for logging in. Everything before that, literally all you had to do is just throw a string at it, and then it would give you all of the information. SNMP is a very useful network management protocol, but much like a lot of protocols that were written in like the early days of networking, insecure by default. And it took them like 3 different versions to finally get it up to a secure place. Thanks. It's a great question. So basically, the proof of concept was revealed in August of 2016. The exploit was then improved on by RiskSense Ops. They're a company that does some stuff. I actually don't even really know what they do. But they put out a version of the exploit that removed some tedious XORs that were used when the original proof of concept was written to make it easier to obfuscate what was going on. And it reused code for calls to sys_mprotect. This function is used to change the permissions on the area of the binary, which are used to authenticate logins. This is really important because the payload itself, unlike most exploits against like software, doesn't just send back a shell or engage in some type of interactivity. Instead, it modifies the binary so that the function that is used to verify if a password is correct always returns true, which was super cool when I actually got this exploit working at like 3 a.m. last semester. When I went to log into the ASA, I used my normal password, which was just SSH, because it's, a development box. And then I like mashed on the keyboard afterwards, and I was able to log in too. It's super neat. My theory as to why they did this is because of avoiding having to figure out a workaround for the watchdog timer. This is something that's in the ASA operating system that basically says if a process doesn't respond to polling for like 30 seconds, reboot the whole thing. This makes sense from like an embedded systems perspective, because if you have a router that is just hanging there and you have like a process that isn't doing anything, instead of just sitting there and not forwarding anything, you would want to try to reboot to see if that can like fix whatever the problem is. And if you have a system that's rebooting over and over again, your network team would probably be able to find out that something is wrong. So the vulnerability affected all of the versions of the ASA operating system over to the right there. The RiskSense proof of concept, however, only targeted certain types of firmware. They included a Python script that would allow you to adapt the proof of concept to other firmware that was vulnerable, but they hadn't tested against it. Basically, the way they did this is that they would search through the entire Lena binary and search for assembly that corresponds to the function for checking admin authentication, checking that passwords are correct, and to find the SNMP handler code so that you could just change the addresses in the payload, because those addresses are going to be static when they're running in the actual operating system because of the lack of security protections I talked about earlier. I ran it on my version of my ASA, which is firmware 916, and here's what happened. It just crashed. This is actually just the, because I couldn't find the screenshot of the crash happening in real time. This is the information that happened afterwards. But basically, when one of these exceptions happens, it just prints out this information and also the entire stack of the ASA in that moment, and then it reboots. So I was like, cool, something broke. Let's fix it. Let's fix it. All right. So my first task that I had to do was actually set up a development environment, which took a little more doing than what I expected. My first attempt was just using my backbook, which seemed like it would work because it's like a Unix system. However, the ASA tools software that NCC group wrote expected the Linux versions of like hexdump and binwalk and everything. So when it tried to run it on my computer, it was like, these flags don't exist. So I was like, all right, cool, let's try to use a VM instead. One of the problems that I ran into with that is that there were other scripts within the ASA tools repository that allow you to automatically modify in IDA different functions that are important for the exploit, like the reverse engineering, and I wanted to try to use these. However, the version of IDA Pro that I had only had a license for Windows. So, final step, switched over to using a Windows VM within my backbook, using Windows subsystem for Linux. So I used the Linux for the firmware scripts, and I used Windows for the IDA scripts. I was actually originally concerned about this because obviously if you're using a router or an ASA, you have to use the serial port to be able to configure the thing and use the underlying CLI. For a while, the Windows subsystem for Linux didn't actually have serial support because the way that they do that was very different from how Linux does the actual device files. But when I actually started doing this area of the project, I realized that they had already implemented it, which was super convenient. I didn't have to figure out like attempt number 4 through 99. So, all right. The first step that I wanted to do was figure out what the shellcode was doing. So basically what happens is it's only 69 bytes, which is like super awesome, very small binary. It stores the original registers onto the stack because when you're running an exploit, you need to put the base pointer and the stack pointer back the way it was before. Otherwise, the program will be like, wow, that changed, goodbye, which will become important a little later on. Then we had to call the sys_mprotect syscall so that we could modify the binary, because normally you're not allowed to write to read-only data in a binary. And then it copied the patch code to the end of the auth check functions before returning back to normal execution after resetting all those registers. So again, here's the error message that I had when I ran the exploit. If we take a look at the crash dump, we can see if we can find anything of use. I realized I need to make a change to this presentation. I meant to have the shell code right next to it. This value, all the way up in EDI, is the value that's set at the end of the exploit before you return execution. So that gave me a hint as to where the problem was actually happening. So the way that I went around fixing that is to use the GDB server in conjunction with IDA Pro. In the shellcode itself, if I hop back right here, there is a safe return underscore offset that is not on this side. It should have been. That basically is just an address where the SNMP, the vulnerable code is. And so if we load that address into IDA Pro and then jump to the start of the function, then we can figure out what address we need to set breakpoints at. So I set a couple breakpoints. One just before it jumped into the vulnerable code. And then this second breakpoint was when execution stopped. So the problem in the exploit. So this is important because if we take a look at what the registers look like, this is what it's supposed to be restored to. And this is what it actually is before returning to execution. And it's very, very small. But the difference here, ESP, it's much easier to see with the stack pointer instead of the base pointer. Before execution is 5C8, but just before jumping back is 5C4. So this 4-byte difference was enough that you would get a segmentation fault when you got to that point of the exploit. Another thing that I had to do, oh, actually I had speaker notes. No, I didn't. Okay, so that was one problem with the exploit. While I was trying to figure out what was going on as well, I used the examine function within GDB, which allows you to look into memory within the program and translate it into certain ways. This allows you to translate stuff into assembly instructions. And if you take a look here, you'll notice that this is what was running in memory, and on the right is the actual assembly source. So you have move the EDI address back into EDI, add EBP4 I took this screenshot at the end when I had already implemented the fix, so let's just ignore that for now. And then the other two instructions, but then there's an interrupt right here. I have no idea why they had this interrupt. But basically what happens when you have an interrupt in like assembly code, everything just stops. Either it like does a syscall or it just sits there if there isn't anything to like do a syscall for. So this was like super frustrating because I implemented that change to increment the base pointer by 4, but it still wasn't working. My theory is that they added this interrupt into the shellcode to make it more difficult for like script kiddies to go around and run this exploit on a bunch of different firmware, because it would just crash it instead of patching the authentication function. So it was a really quick change. I just had to delete, actually, getting ahead of myself. So the solution was I needed to add this EBP instruction right up here so that the base pointer, was set to the right value, and then I removed that interrupt. So now I have a short demo video. This one should be big enough, but we'll find out together if that's the truth. All right. Oh, that's definitely unable to play video. Cool. That's awesome. So basically what happens here, I'll paraphrase, is that I boot up the ASA, crash it with the original vulnerability or the original exploit code, and then I wait for it to reboot, switch over to my newly fixed exploit, run it against the system, it returns perfectly fine, and then you can log in with a bunch of garbage. That's super disappointing that that didn't work, but like I said, that's why I wanted to try out this presentation here where I didn't have like a job on the line. I'd rather disappoint you guys than like future employers. Yeah. All right. So the main takeaways here are try to avoid tunnel vision. It can be really easy to fall into a pattern of assuming that something you're looking at is way more complicated than it actually is. I came into this project without having any experience with like reverse engineering or proper like binary exploitation troubleshooting beyond like basic buffer overflows. So for instance, I was unsure in IDA if the program addresses that I was looking at were the actual like addresses that it would be when the code was running. What could have been just a very easy Google search became an hour of me trying to get a reverse shell payload to work that would like call back to my system with the Linux, with like actually being able to reach the Linux operating system, and then looking in the proc directory for the ASA, and then being like, oh cool, yeah, the addresses do match. So that's like super important with any big project, but especially with this type of reverse engineering, because you can lose like, I lost literally an hour on this project just doing that, which was pretty stupid. The other thing is that like the best way to learn a new area of your field is by starting a personal project. This helped me understand that what I originally thought was like black magic being performed by reverse engineer sorcerers somewhere far away from me was crazily enough straightforward and logical. The best way I've been able to push through that tendency to assume that like foreign technical concepts are impossible to learn is just by jumping into the deep end and working on a project like this. Finally, not every threat actor is going to exploit your systems in traditional ways. Very easy to assume that like every single exploit you're going to get are just going to have shells that go back to some crazy C2 that's over in like Belarus, and then you can like log in and change things. It's extremely easy to run this code, and like I've said this every time I've talked about this project before. When was the last time that you tried to log into your router with an incorrect password to see if it worked? So these are my references. Any questions or feedback or anything? Russell.
Hey, I think overall the presentation was really, really good, especially for a professional presentation. I thought you did a great job of breaking down like a lot of complex problems that you're encountering throughout the whole process of you discovering the exploit and working with the POC. So that's great. In terms of questions, and this is maybe just like for other people as well, like what resources did you use to kind of get started with like x86 and kind of learning how to tackle this bigger project?
That's a really good question. So one of the biggest things that helped was...
Repeat the question, please.
Yep, sorry, oh man. You know, I've yelled at so many people for not doing that, and then I've forgotten myself. What Russ said was what resources that I've used to like learn some of the x86 and like figuring out assembly, and then also taking on like a sort of big project. One of the resources I used was doing the practical malware analysis book and like the course that we have here at RIT, because that goes through some of the basics of x86 assembly. But honestly, one of the things that I guess really made more of a difference was taking the concepts of computer systems class before then, which taught us how to do basic assembly, writing things, and specifically how the stack frame is set up at the low level, because like when you run a program, that's just done by default. So I don't have any specific resources for that other than like looking around. I'm sure it's very well documented on the internet how programs operate. So that had a big difference. In terms of like specific technical things, the references that I have over here helped out a lot, especially because the ASA is like embedded software. So it's very difficult for you to like figure out where to start. So reading through some of these blog posts and then other blog posts that are linked within those blog posts helped me gain a better understanding of like how to get started and what I needed to do to succeed. And using GDB a lot, which was pretty cool. If you don't know how to use GDB, if you haven't taken mechanics or the CSEC 201 course, GDB is amazing. It will save you from having to write a bunch of print statements to solve your problems. You could just be like, hey, what does that look like while it's running? It saves you a whole lot of time, and establishing those practices are much like figuring out that you need to floss every night when you're like brushing your teeth. It's kind of tedious at first, but it helps you out and can save your life. Any other questions? All right, thank you. I'm under my time requirement.
It's okay. You got that video too. I don't know how long the video was, but.
Okay, I had the time.
No, I know, but like I'm saying, the video that you didn't get to play because it wasn't working.
Oh yeah, that was about 3 minutes.
Okay, so we'll get you there.
Yeah.
We'll get you there. Okay. All right. So our next presentation for the day will be by Mr. Russell Babarski. It will be upon lessons learned, applying everywhere. And as he begins to walk up here, Russell is a senior. He is the head of education. You might have seen him in the first half. Oh, you're here. Okay. Gotta mic you up, sir.
So when you see me walking out, realize it's because I just don't want to hear you talk.
Yeah, don't worry, Shannon is too.
Okay, yeah.
Nothing.
What you say? So we need to
I
mic
said,
you.
you're a great president. I'm the first lady. She's the president. I'm making, I'm looking.
Watching Designated Survivor, and I was like, yo, fuck president. I want to be
First lady's great. All right, are we good to go, Jack?
Give me a sound check.
1, 2, 1, 2.
I think so.
Okay. Well, I'm really glad everyone left my presentation. I wouldn't want to listen to it anyways. Oh, thanks, guys. Hey, it's good to see you guys.
This is really important
sucks that I'll run out of new jobs.
Right, yeah. Well, so.
Guess what's coming up soon? Job fair.
Yeah, career fair, woo! So, yeah, I've been searching for a job for the past like 6 months. And I'm just kind of up here to preach and give you guys basically some lessons I learned throughout the time that I was searching for jobs and kind of mistakes I made and stupid things I did and like stupid things I said. And hopefully you guys can like take that information and apply it to your own job search, either when you're going full-time or even for co-ops. But this is definitely more for like full-time because I'll be discussing certain like salary things. So, but anyways, yeah, I guess we're at my backstory at this point. So yeah, I've been searching for a job for the past 6 months. I'm still kind of looking, and I have a few options on the table, so I can't, you know, I'm not going to be up here like revealing like, oh, this is where I'm going to go at the final slide. So that's sad, but you know, I'm hoping that this presentation is useful to a lot of you, especially underclassmen that maybe don't have a lot of experience in, you know, negotiating, talking with companies, because there's like a lot of nuances and stuff that I learned, and like, you know, sitting through like hours on the phone with my dad and him like lecturing me on like how to actually speak with these companies and, you know, what to say and what not to say. So I guess just hopping right into it is my first lesson is sell yourself. Have you guys seen, was it Wolf on Wall Street? Yeah, everyone's seen it. It's an older movie. It's like probably like, what, 8 years old now? That's like really old. But you know, at the end, right, he does, not to spoil it for you guys, but he does like, you know, sell me this pen thing, right? You guys remember that? Yep. Okay, yeah. So like, you gotta be like that guy where he's like trying to sell you a pen to the guy from Wolf on Wall Street, right? You really want to sell yourself. And I had a problem with this in that I would kind of rely on like all the things that were on my resume. You know, I'm like, oh, do CCDC, right? I did CPTC. I have my OSCP. Like I have all these great things. I have work experience. So I just assumed that like companies knew how awesome I was and that they would just be like, oh, we love you. Like, please come work for us. Here's a blank check, right? I didn't actually think that, but yeah, they don't really do that. You have to really sell yourself and really advocate for yourself. You know, at the end of the day, you're your biggest advocate, and they're not really going to believe you or your skills unless you tell them or unless you really sell them. So like that's one of the things I really struggled with at first is I would kind of like almost undersell myself or not really like tell them, hey, this is why I deserve this amount of money or this is why I deserve like this signing bonus, right? I never would do that, and you really got to do that because companies, you know, they're going to try to buy you out for like the cheapest amount, and they need a reason why that you are worth the amount you are, right? So that was probably one of the biggest lessons is, you know, really don't come off cocky, right? You don't be like, oh yeah, you know, I'm the best pen tester in the world. You know, I got like rank 157 on Hack the Box, so I'm amazing. You know, you don't want to come off like a cocky asshole, but you want to come off as confident in your abilities and that you have a desirable skill set, right? So lesson number 2, and this was an interesting one to learn, and maybe some people might disagree with this, but I always say don't give them a number. What I mean by this is when they approach you, oftentimes companies will say, hey, so what is your salary that you want? And I had that happen quite a few times, and pretty much every company I interviewed with, if I got to that step, right, where they're going to give me an offer, they would ask me that question. And so I would sit there and, you know, stupid me, I didn't have a number in my head. So I'd have to like think on the spot, right? Like, okay, what salary do I want? What's a reasonable salary? It's kind of a bad idea to give them a number. And the correct response oftentimes is to not give them a number. And the reason is oftentimes maybe not in this field, maybe just in general, but people sometimes will undersell themselves and like give them a lower number than they actually would receive originally. So a little story behind this. My dad, I think he was applying to this new job, and he was at that point, right, where he was going to get an offer, and they asked him, well, what do you think you're worth? And so he's thinking, you know, like, oh, like, and he was a business, you know, like, had a couple years of experience and was a businessman, so he's looking at, oh, like 50, 60,000, right, or something in that ballpark. These are just all like numbers, but this is just an example. And he's sitting there thinking those numbers, but he was like, okay, well, I'm just not going to say anything. I'm going to put the ball in their park, right, and let them tell me what they think I'm worth. And so he did that, and they ended up coming back for like 20 or 30,000 more than he originally thought. Now, how stupid would he have thought he would have been, or he wouldn't even really know, but that would have been really awful if he would have been like, oh, I'm worth like 50,000. The company would have been like, oh yeah, great, like you're worth 50,000, like come work for us, please, right? That's $30,000 that they're back in their pocket that he missed out on. So, you know, there's no real reason to give him a number unless they're like absolutely demanding it. most of the time, you know, put the ball in their park and see what they say, see what happens, see what they offer you. You can always counter and negotiate with them. If they aren't willing, then, you know, then apparently they're not worth it, right? So lesson number 3, and this comes as maybe an obvious to some of you, but to me, I honestly didn't do my due diligence a lot of the time and didn't really research the company enough. So researching the company and really having an actual understanding of the company culture and what they do behind the scenes is really important. And I had a chance for one company. I was doing a phone interview, and I kind of got caught with my pants down, where they were asking me a lot of questions that if I would have done more research on the type of work that they do, it was really the pen testing and the type of like pen testing methodologies that they used. I would have been much more prepared and would have had like a good idea of like, okay, here is what they do, like here's some of the techniques that they use. It was literally like all up on their blog, right? All I had to go do was like read the blog, but of course I didn't, and that was really stupid. And that was a big mistake I made, and like I said, I got in the interview and the guy was asking me questions related to these techniques that they used and kind of my familiarity with them, and I just had like no answer for them. I was like, I've never really used that tool, or I've never learned that language, right? And that's super embarrassing, and obviously I didn't get the next phone call back. So as obvious as it may sound, you know, it's just really important that you really understand the type of work that you're going to be doing going in, and having a good understanding of what type of you know, methodologies, and really just have a good understanding of the company as a whole. And you can also like look into company culture and stuff like that through their website and kind of get a good feel for it as well. And we'll talk about that a little later, but that is just a really important one. So this one comes from me from my junior year. So a little backstory for this one. Be patient, don't act on emotion, is that I was in my junior year, and it was like the first, I think it was the fall semester. And so I was like searching for a co-op, right? It was my last co-op. And I was basically, okay, like I'm a junior now, I have more experience, you know, I'm working my OSCP, so I'm a little bit more marketable. Surely, like, you know, I'm looking at big numbers, right? I want the big bucks this semester. So yeah, I got a really good offer from one company, and I immediately like jumped on it, right? It was like a really like nice paying hourly number. I was like, this is it, like I've made it, right, you know? And I immediately like jumped on it and gave him gave the guy that was hiring me like a really quick yes. And yeah, I didn't end up going there. So that was a huge mistake. I really quickly jumped on that offer and just saw the, you know, the number, right? The single digit, it wasn't single digit, but like the one number, right, that they gave me, and that's all I saw. I didn't see like the location or like anything else. I didn't see anything else, right? That's all I saw. It was a very narrow view, and I didn't really give it a lot of thought, and that was a really big mistake. And it, not only when I had to call the guy in the spring and be like, actually, yeah, no, I won't be there, right? I had to really like backpedal, and that was just a big mess, and it made me look bad, and it was a problem for the company that I was going to work for. It all worked out in the end, thankfully, and it didn't, you know, cause me to obviously like not graduate in time or anything like that. But yeah, definitely like really think about your decisions that you're making, especially with a co-op full-time, especially full-time. I mean, I think that goes without saying, but even co-op, like, don't just jump at a number because they're like, oh, we're gonna offer you like $45 an hour. Don't be like, oh yeah, like yeah, sure. And then you know, you find out that like, oh, you're living in San Francisco, and yeah, your rent's gonna be $2,000 a month. What? You're like, $45 an hour is like nothing out there. You buy you like an In-N-Out burger once a night, but. In all seriousness, yeah, just really take your time when you're deciding your offers, and don't jump the gun, because I know I learned that lesson the hard way. And lesson 5, the classic saying, be yourself, right? It's so cliche, but it's really true. A lot of companies, a lot of times, you know, I always say, or my parents always would tell me, when you're going to talk to these companies, like, trust your gut feeling. Look at how they act, look at how their culture is compared to how you are and your culture. Like personally, I know I'm not like a huge like drinker, like I'm not a big like social drinker or anything like that. And there's some companies out there that really advocate for that and are really like big on like, oh, social drinking, like we have a bar in our office, right? We're drinking all day. Not that, but you know what I'm saying? Like that company probably wouldn't be a fit for me since I don't drink a lot, right? That wouldn't make any sense. Why would I go there? I'd be like totally out of my element. So yeah, just you know, aligning, seeing if your values align with the companies. And at the end of the day, they're like, it's like a mutual relationship, right? Like a lot of times we feel like it's like a desperate situation where we're like trying to convince them to hire us, but really it's like a two-way street, right? Like they're seeing if we're a good fit for, they're seeing if they're a good fit for their company, but we're also seeing if they're a good fit for our lives and like our lifestyle and our beliefs and our, you know, what we associate with ourselves. So that's like a lot of times I see people kind of just look at, you know, the money and like what the work they're doing when they don't even consider like the other facts that, you know, the people you're working with or just the area you're living in or, you know, whatever, right? So it's not the biggest deal for co-ops, but for full-time especially, since you're going to be there for a year or two, it makes a big difference, because if you're miserable for like a year or two and you don't like the people you work with, then you're really going to hate your life. So, but yeah, this is like a really quick presentation. I don't really have any more lessons. I guess just to end it and kind of, you know, seal the bag in this case, you know, searching for full-time jobs, especially and even co-ops, is really difficult, but don't get discouraged. I've had a lot of times where like throughout the 6 months I've been really discouraged and been like, you know, what the heck, like, why can't I find a job? I have all these skills, I have all these abilities, like, am I not good enough? But it's, you know, it takes a lot of time, and yeah, so just don't get discouraged, and just, yeah, that's all I got. Thank you guys. Oh, any questions? Yeah. What's up?
Question for you, and
Sure.
I guess if anybody else wants to answer this, it's more of a discussion thing. Have you ever had, like, they call them exploding offers, when somebody gives you an offer and then you have to respond, like, in a week or something? They don't really give you much time to deal with it. Have you ever dealt with that? How do you suggest it?
Yeah, I mean, you just gotta like. Oh yeah, sure. So the question was, how do you deal with exploding offers and offers that are very like have a quick turnaround time? So they give you like a 5 days or a week or maybe less to decide. So I dealt with that once, and that was with a very popular security company for a co-op. And that was hard because it was like a company I actually considered, but it was such a quick offer, and it was like very in the beginning of, I think it was my junior year, so it was in the fall, like the very early on, like right after the career fair. So like I was still hearing back from everyone, and I just, honestly, I had to move on from them because I wasn't sure what other offers I was getting, and you know, unless you're really sold in that company and that's like your dream co-op or your dream job, I think it's best to avoid those exploding offers as much as possible, because oftentimes if they are making an offer that quick, there's probably something wrong in the background that they're not telling you. So just my advice, but other people may disagree.
You should also report them to the RIT co-op office.
Oh, very good point, yes. That's, that they should not be doing that, and the RIT will definitely reach out to them and explain to them, you know, the problem with that. So good point, Nick, thank you. Allison. Yeah, that's definitely another point I could have made, is like ask a lot of questions. Sorry, I do it all the time, repeating the question. So Allison just asked, what kind of questions do you ask when you're trying to find out if the company is a good fit for you or not? I would say, you know, asking a lot about, I always heard a good one was, do the coworkers go out to lunch often, or do they hang out after work, right? That kind of gives you a good idea of if the people are, you know, social, are they friends? How do they get along, right? Is there a lot of teamwork on the team? I always like to ask about just kind of like what their hobbies are and like what they do outside of work oftentimes, because especially for full-time jobs, a lot of times we go out to dinner with the full-time employees and kind of get to meet them like one-on-one outside of the interview room. And that's a good time to ask about like their lifestyle, like what they do, how much they commute, like, and just get to know them better, right? And that's usually a good indication of kind of what kind of people you're going to be working with. And you know, if the guy's like, oh yeah, well I try to get out here as quick as possible, and man, yeah, we don't really hang out much outside of work, then that might be a bad sign, and that the team doesn't really work very well as a whole. So, but hopefully I answered your question. So I was a little bit rambling. Does anyone else have any other questions? Cool. Thank you guys so much.
Okay. Well, we have one more presentation, but first,